Hello, I want to take this opportunity to provide a gentle introduction to some analytical terms and techniques. Part of what makes learning a new subject difficult is just getting used to its language, and analytics is full of words that you may initially find to be vague. My goal is to present everything in simple language. There will be no math. Analytics is the process of extracting insights from data. You may have heard the term data analytics before and wondered if the word data is redundant here, since all forms of analytics analyze data. Well, it does sound a little redundant. It's kind of like saying, after we do some data analytics, we're going to McDonald's to do some food eating. I've never really heard a data scientist say data analytics before, but I think we can probably figure out why business people might say it. It may be to differentiate their general application of analytics from more specific forms of analytics, like web analytics, retail analytics, or risk analytics. I suspect that they don't want their audience to envision BI dashboards when they say data analytics, but instead want them to think about the more rigorous form of analytics where predictive models are built to uncover hidden insights. Another thought is that people in the business world tend to prefer the term analytics over mining. For example, you usually hear business people talk about text analytics, while the term text mining is used more often in academia. So data analytics may be a more business-preferred way of saying data mining. When I did graduate studies in data science, we did a lot of data mining. Data mining is the process of using analytics to discover patterns and predict likely outcomes. Since I mentioned data science, I should define it too. Data science is a profession that requires skills in multiple areas, including data management, data engineering, data mining, and data visualization. It's the data mining part of a data scientist job that most people are thinking about when they say analytics. If you think of data as raw material and the insights that you can glean from the data as something valuable, then the process of extracting the insights can be compared to mining gold from rocks. Another term that you'll hear related to data mining is machine learning, which can also be defined in various ways. But I like this sentence that I heard from one of my professors. We use machine learning algorithms to perform data mining activities. So when we do data mining, we use machine learning procedures to discover insights. People tend to mix these two up just like they do with natural language processing. They will say that they are doing NLP when what they really mean is that they are using NLP algorithms to do text mining. The machine part of machine learning obviously refers to computers, but you may be wondering where the learning part comes from. Instead of hand-coding software routines with explicitly programmed instructions about how to accomplish a task, a computer is trained using data and algorithms to give it the ability to learn how to perform a task. A term that you will hear sometimes when machine learning is discussed is artificial intelligence. Artificial intelligence is the ability of a computer or robot to perform tasks like a human. The dream of AI pioneers was to construct complex machines that possess the same characteristics as humans. This is the concept we think of today as general AI. Machines that have all of our senses, all of our reasoning, and think just like we do. What we can actually do falls into the concept of narrow AI. Technologies that are able to perform specific tasks as well as humans do. Examples of narrow AI include Facebook's facial recognition, Pinterest's image classification, and Google's self-driving car. AI technologies exhibit some aspect of human intelligence, and that intelligence comes from machine learning. Machine learning came directly from the minds of early AI practitioners, and their algorithms included things like decision trees, clustering, and reinforcement learning. Another algorithm that came from the machine learning crowd is called artificial neural networks. Artificial neural networks are machine learning algorithms that are loosely modeled on our understanding of how the human brain works. Deep learning is a buzzword for artificial neural networks. There are too many data mining algorithms to discuss all of them now, but there are only a few fundamentally different types of tasks that these algorithms address, and I will concentrate on 4 of these. Classification is an attempt to predict which class an individual belongs to. An example classification question would be, among all of our customers, which ones are likely to respond to a given offer? In this example, there are 2 classes, and they can be named will respond and will not respond. For a classification task, a data mining process produces a model that, given a new individual, determines which class that individual belongs to. A task that is closely related to a classification is scoring. For a scoring task, a data mining process produces a model that, given a new individual, determines a score representing the probability that the individual belongs to each class. In our customer response scenario, a scoring model would be able to evaluate each individual customer and produce a score of how likely each is to respond to the offer. Regression is an attempt to predict a number for some feature related to an individual. An example regression question would be, how much will a given customer use our service? The feature to be predicted here is service usage, and a model could be generated by looking at other similar individuals in the population and their historical usage. For a regression task, a data mining process produces a model that, given a new individual, estimates the numeric value of a particular feature specific to that individual. Regression is related to classification, but the 2 are different. Classification predicts whether something will happen, whereas regression predicts how much something will happen. Clustering is an attempt to group individuals together based on their similarity, but is not driven by a specific purpose. An example clustering question would be, do our customers form natural segments? Clustering is useful in preliminary explorations to see which natural groups exist because these groups may suggest other data mining tasks. Clustering is also used as input to decision-making processes, focusing on questions such as, what product should we offer, and how should our sales teams be structured? Association is an attempt to find associations between entities based on transactions involving them. An example association question would be, what items are commonly purchased together? While clustering looks at similarity between objects based on the object's attributes, association considers similarity of objects based on their appearing together in transactions. For example, analyzing purchase records from a grocery store may uncover the fact that beer is purchased together with diapers much more frequently than we expect. Co-occurrence of products in purchases is a common type of grouping known as market basket analysis. Some recommendation systems also perform a type of affinity grouping by finding, for example, pairs of books that are purchased frequently by the same people. People who bought Moby Dick also bought Treasure Island. The result of association is a description of items that occur together, including statistics on the frequency of the co-occurrence and an estimation of how surprising it is. Consider two questions that we might ask about our customers. Do our customers naturally fall into different groups? Here, no specific purpose or target has been specified for the grouping, so this is called an unsupervised data mining problem. Can we find groups of customers who have particularly high likelihoods of canceling their policies? Here, there is a specific target defined. Will a customer leave when their policy expires? And segmentation is being done for a specific reason, to take action based on likelihood of churn. So this is called a supervised data mining problem. Supervised tasks require different techniques than unsupervised, and the results are often much more useful. Clustering is an unsupervised task, and it produced groupings based on similarities, but there is no guarantee that these similarities are meaningful or that they will be useful for any particular purpose. A supervised technique is given a specific purpose for grouping or for predicting a target. Another condition must be met for supervised data mining. There must be historic data for the target. The value of an individual's target is often called its label, emphasizing that often we must incur expense to actively label the data. Classification and regression are generally solved with supervised methods. Clustering and association are generally unsupervised. I created this diagram to show that artificial intelligence currently has 8 major goals. I've displayed each goal in red and have given examples for each in green. Earlier, I described what C3PO can do as general AI. General intelligence is the ultimate goal of AI. It's when a machine can perform any task that a human can. The goal of knowledge is to represent information about the world in a form that a computer can use to solve complex tasks. The goal of learning is to give computers the ability to learn without being explicitly programmed. The goal of natural language processing is to give computers the ability to understand human languages. The goal of perception is to use input from sensors to draw logical conclusions about different aspects of the world. The goal of planning is for agents like robots and unmanned vehicles to be able to make predictions about how their actions will change their current state and environment. The goal of reasoning is to give computers the ability to imitate the step-by-step reasoning that humans use when they solve puzzles or make logical deductions. The goal of robotics is to design, construct, and operate robots and the computer system used to control them. So when people perform analytics and refer to them as artificial intelligence, they are most commonly referring to machine learning or NLP functions. One of the fundamental ideas of data mining is finding informative features about the individual described by the data. In other words, select a subset of a record's variables to use for model construction. What exactly it means to be informative varies among applications, but generally, information is a quantity that reduces uncertainty about something. So, if a pirate gives you information about where he buried his treasure, this doesn't mean that you know for certain where it is. It only means that your uncertainty about its location has been reduced. Feature selection is the process of selecting a subset of relevant variables for use in model construction. The idea behind using feature selection techniques is that records can contain many features that are either redundant or irrelevant and can thus be removed without incurring much loss of information. A key to supervised data mining is that we have some target quantity that we would like to predict. Often this quantity is unknown at the time we would like to make a business decision, such as whether a customer will churn. Having a target variable makes it clear why finding informative features is important. Is there a set of features that reduce our uncertainty about the value of the target? This also gives us a common analytics application of the idea of correlation. We would like to find knowable attributes that correlate with our target of interest and reduce our uncertainty in it. A predictive model is a formula for estimating the unknown value of interest. The formula could be mathematical, or it could be a logical statement like a rule, or it could be a hybrid of the two. In common usage, prediction means to forecast a future event. In analytics, prediction means to estimate an unknown value. Supervised learning is model creation where the model describes a relationship between a set of features and a predefined target variable. The model estimates the value of the target as a function of the features. So for our churn prediction problem, we would like to build a model of the propensity to churn as a function of customer account features like demographics, length of time as a customer, number of calls to customer service, and out-of-pocket cost. Analytical techniques have historically been used in several different fields, like machine learning, pattern recognition, and statistics. So as a result, there are often several different names for the same thing. We use a data set whose form is tabular, like a database table or a spreadsheet. A data set contains a set of instances, which are also referred to as rows in a database table or cases in statistics. The features have different names as well. Statisticians call them independent variables, and operations researchers call them explanatory variables. The target variable is commonly called the dependent variable in statistics. The creation of models from data is known as model induction. Induction is a term from philosophy that refers to generalizing from specific cases to general rules. Our models are general rules in a statistical sense because they usually do not hold true 100% of the time. The input data used to induce a model is called the training set. They are also called labeled data because the value for the target variable, the label, is known. The initial discovery of relationships is done with a training set, while a testing set is used to assess the strength of the predictive relationship. I will wrap up now with a summary of a supervised process. There is a difference between performing data mining to build a model and then using the results of data mining to aid decision making. Data mining produces a model by using a training set whose targets are labeled. Then, a testing set with labeled targets is used as input into the model to test the model's accuracy. Then, in the use phase, the model is applied to new instances and predicted targets are generated, which can be used to inform your decision making.